So we've seen the introduction of all of our rotational quantities, so omega and alpha and theta, and we've seen how those can just directly translate our kinematics equations with constant acceleration. Well, with non-constant acceleration, as we saw, those definitions are the same. So just like we had the idea that velocity was the time rate change of position, we know that angular velocity is going to be the time rate change of angular position. So what that means is then I can either integrate or take a derivative even if I don't have a constant acceleration. These fundamental definitions still apply just like they did with 1D motion with non-constant acceleration. So in this case here, then I can say that theta would then be equal to the integral of omega dt. And these are all still time derivatives because they're with respect to time, the time rate change of something. And again, the acceleration was the time rate change of the velocity. So that means then that we can write this as our angular acceleration is the time rate change of our angular velocity, omega. And so then we can get omega from alpha by knowing that we can just integrate. So very, very similar to what we used to do, and we still sometimes do with our non-constant acceleration in our linear world. We also are going to do it in rotation. Now, in rotation, we don't have, in this course, multiple dimensions of rotation. We will have a single axis of rotation, so we don't really have an analog to two-dimensional motion in our rotational motion that we're talking about, because we are going to just stick to rotation around a single axis. However, you can imagine that it wouldn't be much different. They would all just be around a single axis because that's the direction of omega and alpha, as we've seen in previous videos. So when you're problem solving, you're going to do the same thing where you are going to take either the derivatives and the integrals. You're going to use initial conditions when you integrate, and you're going to integrate, or take a derivative with respect to time only. All right, let me know if you have any questions.